Okay, class, picking up where we left off from. We did problem number 3 in the last video, and we ended up with 9.4. Then we started on problem number 4 before the video was cut off. Okay, we have 8.4 times 10,000. Now, what we have here, we have 4 zeros behind the 1 here, and we know that this is a power of 10. So we need to move this decimal 4 places to the right. So we have 1, 2, 3, 4. And what we have here, we will have 3 places we will have to put zeros. So that would end up being 84,000. Okay, now, number 5. Now, if you notice here, we have 0.01 behind the decimal. We have 2 places behind the decimal, and this is also a power of 10. So when we have these 2 digits behind the decimal, we have to move this decimal 2 places to the left. So our final answer would be a negative 0.567. Okay, now we move to problem number 6. First of all, we have a negative times a negative, which is a positive, and we have 319 times 10. Now this 319 does not have a decimal at the end, but remember it's assumed to be a decimal right here at the last number. So we have to move that decimal 1 place to the right. So that would end up giving us 3,190. Okay, now we move down to problem number 7. It says in 2004 there were 76.2 million families in the United States. Write this number in standard notation. Standard notation is the regular way we write numbers. So this is 76.2 million. Now the 76 will be in the millions place, which would be the 10 million and the millions place. Now the 0.2, this 2 here is actually in the hundred thousands place. I could put a comma. So it'll be 2, and then the rest will be zeros. So this is 76,200,000, which is 76.2 million. Okay, now we go to section C. Okay, class, for section 5.3, we have section C, scientific notation. Before we begin scientific notation, let's review what we learned about writing products in standard notation when multiplying decimals to the power of 10, as we did on page 130. So now we have 2.6 times 10 to the 7th power. We know that we will move this decimal 7 places to the right. So it'll be 2, 6, 0, 0, 0, 0, 0. So our final answer here would be 26 million. We have 1.1 times 10 to the negative 4 power. We know we'll move this decimal to the left 4 places. So it'll be 0.0011. Now we have C, 7.4 times 10 to the 9th. We'll move this decimal 9 places to the right. So it'll be 7, 4, and then 8 zeros. So this will be our final answer for this problem here. So it'll be 7,400,000,000. Now we have 3.071 times 10 to the negative 6. We need to move that decimal 6 places to the left. So it'll be 0.000003071. And that will be the final answer here. Now, it says now we are going to start the process of converting from decimal notation to scientific notation. Scientific notation is a form of multiplying decimals that's used primarily to write larger numbers in a shorter form using multiplication by an exponent of 10. So we have scientific notation. A number is expressed in scientific notation if it is written in the form d times 10 to the n power, where d must be a number equal to or greater than 1, but less than 10, and n is an integer. Writing a number in scientific notation. If necessary, move the decimal point to the left or the right to make the number equal to or greater than 1, but less than 10. count how many places the decimal point was moved in step 1 to determine n. If your original number was 10 or greater, then your exponent is positive. But if the original number was less than 1, then your exponent is negative. You must multiply the number you obtained from step 1 by 10 to the number of the exponent you got in step 2. Now, let's apply what we just read. Okay, it says write each number in scientific notation. So the first thing we must do is we need to move this decimal and only have one digit in front of the decimal. That digit must be 1 or greater, but less than 10. So we'll move this decimal 2 places to the left. So we have 6.8945, and that'll be multiplied by 10 to the power of how many places we move, 2. But since we move left, it'll be positive. So this is the final answer. Now we come here, we move the decimal 1, 2, 3, 4 places. So it'll be 2.56 times 10 to the 4th. Now because we move to the right, that 4th power would be negative. Now number 3, it's assumed to be a decimal at the end of this number. So we'll move that decimal 1, 2, 3, 4, 5, 6 places. So it'll be 5.459231 times 10. And since we move to the left, it'll be times 10 to the 6th power. Now for number 4, move 1, 2, 3, 4, 5. So it'll be 7.2 times 10 to the 5th power. But since we move to the right, it'll be a negative 5. Now number 5, we move 1, 2, 3, 4 places. So this would be 4 times 10. And since we move to the right 4 places, it'll be to the negative 4 power. Now for 20, decimals assumed to be here at the end. Move the decimal 1 place. This will be 2.0, or you could just write 2 times 10. Since we moved to the left 1, be 10 to the 1st power. Okay, now it says, so that is it for the scientific notation. It says using decimals in algebra. Evaluate 7y for y is equal to negative 0.028. So we'll substitute. We will have 7 times a negative 0.028. Now we know a positive times a negative is negative. So we know our final answer is going to be negative, so we don't have to worry about the negative sign right now. Now we look here. We want to disregard this decimal and write this as 28 times 7 off to the side. I wrote the 28 because it's a little longer and it'd be a little easier to multiply here. 7 times 8 is 56. Bring down your 6, carry your 5. 7 times 2 is 14 plus 5 is 19. Now we count how many digits we have behind the decimal. We had 3 digits behind the decimal. So our final answer would be first negative, and then it would be 0.196 because we have to have 3 digits behind the decimal, and since our answer here was 3 digits, we would just put a decimal here. Okay, now we go down to number 2. Now number 2 says, is a negative 5.5 a solution of the equation negative 6x equals 33? So what we're going to do here, we're going to substitute in negative 5.5 for x to see if this gives us a positive 33. If it does, we would say yes. If it doesn't, we would say no. First of all, a negative times a negative is positive. So now we'll disregard this decimal and we'll take 55 times 6. 6 times 5 is 30. We have our 0, carry our 3. 6 times 5 is 30, plus 3 is 33. Now we had one digit behind the decimal, so this would be 33.0, which we know 33.0 is actually just 33. So 33 does equal 33, and our answer is yes. Now let's scroll down here to section D. Now section D, for some reason this is scribbled out, but we don't have to worry about that. We have section D, finding the circumference of a circle. The distance around an object with straight sides, triangle, rectangle, etc. is called the perimeter. You know, the perimeter just means the distance around. Now the distance around a circle is called the circumference. The circumference is just basically the perimeter of a circle. It signifies that you're dealing with a circle and not those straight side figures. Okay, now the definition of the diameter. The diameter is the distance from one end of the circle through the center of the circle to the other end of the circle. Now if we look here, well, before we do that, let's take a look at the radius as well. The radius is the distance from the center of the circle to one end of the circle and is half of the diameter. Now if we look here, we got one end of the circle here, one end of the circle here, and it goes through the middle of the circle, which is here. So this right here off to the side is the diameter. So this long line here from one end through the center all the way to the other end is the diameter. Now for the radius goes from the center of the circle to the end, to one end of the circle. So this right here is the radius. And whatever the diameter is, the radius is just half of it. Now, so if we take double the radius is the same as the diameter. Now we go down here. There are two useful formulas for the circumference of a circle. You have C is equal to pi times the diameter, and C is equal to 2 times pi times the radius. This D stands for diameter, this R stands for radius, and this capital C stands for circumference. Now it tells us here where the value of pi is approximately 3.14. Now pi is a number that goes on forever and does not repeat. So we use the approximation 3.14. So 3.14 is not an exact number for pi. Now it says here, think about these two formulas. Why are they really the same? They're really the same because we know that the radius, okay, the diameter is twice the radius. Remember we said the radius is half the diameter, so it'll take 2 times the radius to equal the diameter. And I'll give you for instance. If the diameter, well, let's say the radius is 8, and the diameter will have to be 16. Now, if we wanted to find out the diameter from the radius, all we would have to do is multiply the radius times 2. Isn't 2 times the radius here? Wouldn't that be 16? Which is the same as the diameter. Okay, so now we go down here. We have a note about pi. Now you can read this at your leisure, but let's take a look at this example. It says find the circumference of a circle whose radius is 11 meters. Then use the approximation 3.14 for pi to approximate the circumference. Since we're given the radius here, let's use the circumference to use the radius. C is equal to 2 pi r. Now, we know we're given that pi is approximately 3.14 and the radius is 11. Now we could put these in parentheses. We always do that when we substitute. Now we could take 2 times 3.14, so we could go off to the side and take 314 times 2. This will give us 8, 2, and 6, and we add 2 digits behind the decimal. So this will give us 6.28 times 11. Now we could go ahead and drop the decimal again. 628 times 11. 1 times 8 is 8, 1 times 2 is 2, and 1 times 6 is 6. We add our 0 here. 1 times 8 is 8, 1 times 2 is 2, and 1 times 6 is 6. So we add this up. We will have 8, this is 10, carry a 1. 1 plus 6 is 7, plus 2 is 9. And we'll bring down our 6. Now again, we only had 2 digits behind the decimal. So our final answer here would be the circumference is equal to 69.08. And remember, we started off with meters, so we'll end it with our unit of measure. And that's it for that problem. Now let's look at objective E. These are our last 2 problems. It says solving problems by multiplying decimals. A biology major is fertilizing her personal garden. She uses 5.6 ounces of fertilizer per square yard. The garden is a rectangle that measures 7 yards by 4.5 yards. How much fertilizer does she need? So the first thing we need to do is take the area of this garden. The area is equal to length times width. Now we're given the length at 7 yards. And our width is 4.5 yards. Now we're going to go off to the side and multiply this. We'll drop the decimal and we'll take 45 times 7. 7 times 5 is 35. We carry our 3. 7 times 4 is 28, plus 3 is 31. Now we add 1 digit behind the decimal, so this will give us 31.5 square yards. Now, we wanted to know how much fertilizer does she need. She uses 5.6 ounces of fertilizer per square yard. So we will have to drop the decimal because we need to multiply this. We need to take this answer, 31.5, and multiply it by 5.6. Now we're going to drop the decimals. So we add 315 times 56. 6 times 5 is 30. We carry our 3. 6 times 1 is 6, plus 3 is 9. 6 times 3 is 18. Add our 0 here. 5 times 5 is 25. Bring down our 5 and carry our 2. 5 times 1 is 5, plus 2 is 7. And 5 times 3 is 15. Now we add them together. This is 0, 14. 1 and 8 is 9, plus 7 is 16. Carry a 1. 5 plus 1 is 6, plus 1 is 7. And you bring down your 1. Now here we have 2 digits behind the decimal. So our answer here would be 176.40, and then it's ounces. Now that takes care of that problem. Now we look at problem 2. A car's tires are 22 inches in diameter. How far does the car travel with 1 revolution of the tire? Now 1 revolution means that it goes completely around. So basically we're doing the circumference. Circumference is, well, we could use, actually we should use pi times the diameter, because remember, we're given the diameter. Now even though it doesn't tell us to use 3.14 for pi, when it doesn't state that, typically we will use that measurement approximation of 3.14. So we add 3.14 for pi, and then our diameter is 22. Now we multiply that. 3.14 will make that 314 times 22. 2 times 4 is 8. 2 times 1 is 2. And 2 times 3 is 6. Add our 0. 2 times 4 is 8. 2 times 1 is 2. And 2 times 3 is 6. Now we add them. We have 8. This will be 10. 1 plus 6 is 7. Plus 2 is 9. And we bring down our 6. We add 2 digits behind the decimal. So it'd be 69. So our circumference is 69.08. And remember, we were dealing in inches, so we have to put our units of measure. And that is the end of this section.